In this question, it is given that the point A is 3 minus 4, the point B is 1, 2, and P is the variable point having coordinates 2k minus 1, 2k plus 1. And you have to find the value of k so that the length PA plus PB is minimum. This question I have taken from a very popular book of JEE. The solution given in that book is absolutely wrong. First, let me tell you the procedure which that book has given. While I am doing the question, see carefully each and every step and see whether you are able to find the mistake before I reach the last step. That book has used the concept of triangle inequality, and the triangle inequality is if ABC is a triangle, remember that sum of any two sides is always greater than third side. That is, this length plus this length is always greater than this length. Equality is possible only when A comes on the line BC. When A is outside, then in that case AB plus AC will be surely greater than BC. And now I am going to use this concept in this question. According to the concept I just now told you, according to that concept, the least value of PA plus PB will be equal to AB, because if A and B are fixed point, PA plus PB will be least when P comes on the line AB. That is when PAB are collinear, and the least value of PA plus PB will be AB. But he is not asking the least value of this, he is just asking the value of K so that this becomes least. And this will be least when PAB are collinear. And using the condition of collinearity, area of triangle is 0. That is, you will get 1 by 2, 3 minus 4, 1, 1, 2, 1, 2k minus 1, 2k plus 1, 1, putting it equal to 0. And after opening this determinant, you will get the value of k as 7 by 8. That is when the value of k will be 7 by 8. At that time, PA plus PB will become least. But actually it is wrong. What is mistake in it and what is the proper way? Now I will tell you. To understand the mistake, let me first find the locus of the point P. We know that whenever you have to find the locus of some point, we always suppose that point as HK, and after that we try to find a relation in H and K which is not containing any other variable except H and K. Once that relation is found, after that we write X for H and Y for K, and we get the equation of locus. But in the present question, K is already involved in the question. Hence, instead of supposing the point P as HK, we suppose the point P as alpha beta. To find the locus of the point P, clearly now alpha is equal to 2k minus 1, beta equal to 2k plus 1. And now to get the relation in alpha and beta, which is not containing any other variable except alpha and beta, for that subtract the two equations. I get beta minus alpha equal to 2. And because this is a relation which is not containing any other variable except alpha and beta, hence this is a proper relation. And now we write X for alpha and Y for beta. I get Y minus X equal to, that is Y equal to X plus 2. And now see the figure formed. A is the point 3 minus 4. 3 minus 4 is somewhere here. B is the point 1, 2. And as the locus of P was y equal to x plus 2, it is 2 here because this point is having y coordinate 2. It means P moves anywhere on this line. Previously I told that PA plus PB is greater than equal to AB. That is the least value of PA plus PB is AB. But you can see very easily that wherever P moves on this line, PA plus PB will never be equal to AB. PA plus PB equal to AB is possible only if P lies somewhere between A and P. But because the locus of P is this line, therefore wherever P moves on this line, PA plus PB will never be equal to AB. Hence it is wrong to say that the least value of PA plus PB is AB. If this is wrong, then what is the proper way of doing this question? To understand the proper way, first see this concept. Suppose this is x-axis, y-axis, this is a point C having coordinates say 2, 3. This is a point D having coordinate 5, 7. And you have to find a point P on x-axis such that CP plus PD is minimum. That is CP plus PD I want to be minimum. It is obvious that the least value of CP plus CD is not CD because P can never come on the line segment CD. P can move only on this line only. To find the least value of CP plus CD and also coordinate of the point P such that CP plus CD is least, see the concept I am going to use. I take the image of the point C in x-axis, that is image is somewhere here. It is clear that wherever P moves on x-axis, CP will be always equal to C dash P and C dash P plus PD. C dash P plus PD. The least value of this will be when P comes somewhere on x-axis such that C, P and D are in a line. That is when the point P reaches here, at that time this will be least. And wherever P moves, CP is always equal to C dash P. Therefore, for this position, CP plus PD will also be least. And if this point is 2, 3, this point will be clearly 2, 1, 3. And now this point is known to you, this point is known to you. You can easily find the equation of this line and get the coordinate of this point. But even better way of getting the coordinate of this point is this. Draw perpendicular. Draw perpendicular. For clarity purpose, I am removing these lines. This is the point P now. Clearly this point will be having x coordinate 2 and this point will be having x coordinate 5. Instead of finding the equation of C dash D and putting y equal 0 in that equation is a bit lengthy, better is, because these two triangles are similar, this length is 3, this length is 7, Therefore, this length is to this length will also be 3:7. And now the ratio is known to you. Points are 2 and 5. You can easily get the coordinate of the point P as writing 3 here, 7 here. 3 into 5 plus 7 into 2 upon 3 plus 7. 29 by 10. That is, this point will be having coordinate 29 by 10 comma 0. Therefore, for this point P, C dash P plus PD will be minimum. That is, CP plus PD will be minimum. As I told you just now, to find the least value of AP plus BP, first we find the image of the point B in the line y equal to x plus 2. As I told you just now, to find the least value of AP plus BP, I find the image of the point B in this line. Note that I could use the image of A also. That is also not a problem. Both are equally good. I take the image of the point B in this line and let this point be B dash. Suppose this point be alpha beta, and we know that if this is the line AX plus and this is the point x1y1, this is the point x2y2, and to find the value of x2 and y2, we know the formula is x2 minus x1 upon A, y2 minus y1 upon B is equal to minus 2 into ax1 plus by1 plus c upon a square plus b square. Hence, we have got the value of alpha as 0, beta as 3. That is the point B dash becomes 0, 3. That is the point B dash is on y axis. Clearly, AP plus BP is equal to AP plus B dash P. And AP plus B dash P will be minimum when situation is of this type, that is P reaches here. For this position, B dash P plus AP will be minimum, and the minimum will be equal to AB dash. Therefore, AB dash is equal to 9 plus 49, that is under root 58. And now if I want to find the value of k, then we'll have to find the value of k for this point. Note that you may be thinking that it is a lengthy solution. No, it is not lengthy. Actually, this was a subjective question. Let this point be C. And now to get the value of k, let us put the point P, that is 2k minus 1 comma 2k plus 1, in this equation of AB dash. That is this. That is 7 into That is, I get 20k minus 4 equal to 9. That is k equal to 13 by 20.